three-dimensional problems, we are going to investigate to find out the vertices of the given figure of a given diagram, etc. So here, there is the work example in which you can see, you can also solve the worked examples yourself. There are practice now questions. I'll also give you some homework related to the practice now. Now, I am going to start the exercise, although all the ideas related to this three-dimensional given to you, because the idea of trigonometry and further trigonometry or bearing may be applied here. So whatever is being done in the previous chapter, that is applied. Now, I'm going to solve exercise 9C, 9C question number 1. Here the diagram is given like three-dimensional. This is a three-dimensional diagram. This shaded region is on the floor and this is a vertical line. Please consider that what is the shape of a three-dimensional figure, because in the three-dimensional length, breadth and height, all the three dimensions are considered. In this diagram, this is the triangle ABC, which is lying on the floor. The triangle ABC is lying on the floor, and at C there is a vertical line CP. CP is a vertical line which is not on the floor, like it is perpendicularly standing like this, okay. So consider this. Now I am going to draw. Actually, the idea of three-dimensional, sometimes few students find it difficult to understand. So please pay your full concentration while solving this. First of all, I am going to draw the figure which is lying on the floor. B is here and the point C is here. This is the shaded region which is lying on the floor. We have to find out the side AC. I am not drawing the complete triangle first of all. First of all, I am drawing the portion which is required. In the A part, first part, AC is required. It is very simple to find out AC with the help of the Pythagoras theorem, because this is 90-degree angle against 90-degree angle. This AC is there. So the first part is very simple. AC square is equal to 7 square plus 6 square. So you can directly find out 7 square plus 6 square, 85, 9.21. AC is 9.21 centimeter. The second part. In the second part, we have to find out PC. Now I am going to draw the vertical line which is given here like this. As you know that it is not possible for us to draw a three-dimensional figure correctly on the piece of paper, so we can just show it like this. Is the line which is coming from the top of P, PB and PA. From the top of P, these two lines are joining at PB and PA. This line is 11 centimeter. Okay. Now in the second part, we have to find out PC. PC mean this perpendicular is required. This is 90-degree angle, because as I told you that ABC is on the floor and PC is the perpendicular. It is something like this. Okay. So we have to find out PC. Now consider in triangle APC. I am considering triangle ACP. AC is already calculated. As you know that AC square, to avoid maximum decimal figure, I am writing like AC square was 85, I think so. Yes, 85. In triangle APC, PC square is equal to AP square minus AC square. AP square. AP square is 11 square. 11 square minus AC square is 85. 121 minus 85. I am not using 9.21. Instead, I am using AC square 85. So very good, bache. Someone has already calculated. So here I am also trying to calculate. PC square is 36. Now here you can see that how I avoided the decimal. This is 6 centimeter. Okay, now you can consider that how we can avoid the decimal figure. I did not use 9.21. Instead of 9.1, I used AC square. AC square directly, I used the value of AC square. Now the third part. In the third part, PAC. PAC, this angle is required. Angle PAC. The third part, PAC angle is required. It is very out this angle because you have all the three sides. So whether you can use sine, cos, or tangent, I am using this is perpendicular over hypotenuse. I'm using sine. Yes, sine. Sine PAC is equal to perpendicular, which is 6 now. We have already calculated perpendicular over hypotenuse. PAC is equal to sine inverse 6 over 11. And please tell me the answer. Okay, many students have calculated this. Yes, PAC. Well, guys, 33.05. Okay, 33.05. Remember this, or you can write 33 degree also. Okay, this is not bearing, so you can write down in 2 digits also. Cos can also be used, tangent can also be used, but I avoided the decimal values. I used because this 6 was not in decimal, 11 was not in decimal. I could also use base over hypotenuse cos or perpendicular over base as tangent. So all the three ratios can be used. But instead of using those in which the decimal places were given, I use this directly so that I can avoid maximum. Uh, how do we correct the math error? Why math error is coming? Actually, there may be any, somebody is asking that um, actually math error comes if your sine or cos is greater than 1. Because I think you might have replaced this value as numerator and this as denominator. This is numerator and this is denominator. Okay. Let me see that what is the question of the student. Someone is asking, sir, how do we correct the math error by changing modes? There should be, yes, we can use the brackets. Okay. Well, now the fourth part is the angle of elevation of P from B. P from B, because P is at the top and B is at the bottom. It means we have to find out this angle. This is the baseline, which is 6, and this is perpendicular. So here we can use tangent theta. The fourth part, angle of elevation, is required. Uh, tangent PBC. This PBC is the angle of elevation from uh, B. This is perpendicular is 6 and base is also 6. You can if you can understand that this is an isosceles right angle triangle, you can directly give that this is 45 degree. If you can directly give by saying that PCB in triangle PCB, rectangle PBC is 6 by 6, so PBC is equal to tangent inverse 1. Tangent inverse 1 is 45 degree. So conversely, you can also say that PCB is an isosceles right angle triangle because this is also right angle. This is also right angle because this is the base and this is the perpendicular. So you know that in the case of isosceles triangle, these two angles are always equal, or otherwise you can solve it like this. Okay, now the next sum, question number 2. In question number 2, you can see that cuboid type figure is given. In this cuboid, we have to find out different things. I am going to draw this cuboid, question number 2. They have shown you something like this. Okay. The sides which are at the back, I am drawing like this. Well, the base is A, B, C, D. This is 3 centimeter and this 4 centimeter. The diagonal is also given. This diagonal length is given, which is 5 centimeter. This height is 12 centimeter, which is now the top side H, E, F, and G. This corner H is joined with the corner B with a straight line. Okay, so here, now let us find out the required thing. In the first part, the length BH is required. The length BH is required. This is a right angled triangle. The base is the diagonal of the base. In right angle triangle, BDH, BDH. This side is 5 and the perpendicular is 12. So directly we can apply the Pythagoras theorem, 12 square plus 5 square. So this is 13 BH, 13 centimeter. Unit is also very important. This was the first part. Now the second part. In the second part, we have to find out BDC angle. Okay, very good. Some students have already calculated. In the second part, BDC, this angle is required, which is on the base. Remember this triangle is on base and this corner angle is of 90 degree because this is a rectangle which is lying on the base and we cannot show this right angle clearly. So remember, at the corner of a rectangle, there is always a right angle. Although it is not looking like a rectangle, but just bring in your mind that this base is a rectangular shape, like a rectangular box. Okay, well, so here there is 90 degree angle, this is 5 and this side is 3. Okay, So you can apply base over hypotenuse. Cos theta can be applied due to the angle BDC angle. So cos BDC is equal to base over hypotenuse 3 over 5. BDC is equal to cos inverse. Thank you so much. Someone has calculated. So you gave me the answer 67.6. Is the answer 67.6 is correct? Because I got two different opinions. Inverse cos 3 divided by 5, 53.1. I am finding 53.1. Please check those who are giving me 67 something, because this is base and this is hypotenuse, and I got this 53.1. Okay, thank you so much. Now the third part. In the third part, we have to find out angle HBD. 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 This angle is required. This right angle triangle is standing like vertical. This is the base of the right angle triangle. This is the height of the right angle triangle, and this is the hypotenuse of the right angle triangle. We have to find out this angle HBD. Perpendicular over base, which is 5 centimeter, we can apply tangent theta. Tangent HBD is equal to perpendicular over base. This is perpendicular, which is 12, and the base is 5. HBD is equal to tangent inverse. Very good. Someone has already calculated. Inverse tangent 12 divided by 5, 67.38 or 67.4. Very good, bacha. 67.4 degree after rounding it off. Okay, the question number 3 is almost the same. Okay, so I am going to solve question number 4, in which there may be some tricky things, because there is one thing which may confuse you in question number 4, and I may leave that confusing thing on you. So be prepared. Again, I am leaving a confusing part on you, because if this will not be a confusing part, if you will solve the confusion while during the course of my solution, then I'll do it with your help. Otherwise, I leave it on you, because I want that you should also do some work. Okay, this is the triangle. Now, how this shape is, please consider this shape. Okay, someone is saying that how this figure is drawn. This triangle, which you can see, AOC triangle is on the vertical wall. Like this triangle is on the wall, and the triangle which I am going to draw now, this triangle is on the floor. It means, please consider this, that this triangle ABC is lying on the floor and AOC is on the wall. It means the angle between these two triangles, is also 90 degree. This angle which I am mentioning, this at point P. At point P, the angle between these two triangles is of 90 degree. And also this is 90 degree, this is also 90 degree, and this is also 90 degree. He has mentioned 390-degree angles. It is very important to understand the figure, because unless you understand the figure, you cannot solve the sum properly. So remember this A OC is on the vertical wall, and this is on the horizontal ground. Now let us read the question. The figure shows 3 points A, B, C on the horizontal ground where A, B, C is a right angle triangle. AOC represents a vertical triangle wall with P as the foot of the perpendicular from O to AC. This is the foot of the perpendicular. This is the perpendicular OP, and this is the foot of the perpendicular. Okay. Now, given that APB is 90 degree, APB is 90 degree, and these rest of the sides are given. We have to find out BAC. The first part, we have to find out the angle BAC. BAC angle, it means this angle is required to be found. As you know that this side is 10, but we are not given with this side AC. Very simple that you can find out this side AC with the help of the Pythagoras theorem, because if you are going to find out this angle now, so even then you can find out the angle BAC, because this is a right angle triangle. So BAC base, this is perpendicular, and this is base, this is hypotenuse. In triangle ABC, because you know that ABC is a right angle triangle, this angle is required, BAC angle is required, this is perpendicular and this is base, so you can directly apply tangent BAC is equal to perpendicular 15 over 10. So BAC is equal to first tangent 56.3. Okay, thank you much. 56.3 degree. Well, so I have done the first part. Length AP is required. It is a difficult task. I think so. I think this task will be easier for you. For some students, it may be difficult task to find out the side AP. The length AP is required. Then what should I do to find out AP? Well, suggest me. I'm seeking your suggestion. Which triangle should I consider? Just name the triangle to find out AP. Which triangle should I take, and which concepts should I use to find out AP? Well, waiting for your answer, and especially those who are very good students. All of you are very good students. Okay, very good. ABP triangle. Somebody has asked me that APB triangle can be taken. You can see that APB triangle is a right angle triangle. APB. So I'm making some suggestion angle. I have to find out the side AP. I have already calculated this angle. So base over hypotenuse. Okay, someone has already calculated. Very good, bacha. So base over hypotenuse, because you already calculated this, and this is a right angle triangle. Here is a right angle. So to find out the AP side, base over hypotenuse is equal to cos theta. Base is AP, and against this degree angle, this is hypotenuse, which is equal to cos of this 50.3 degree. So AP is calculated. Please tell me the sort of on the paper now. Then screen gets blurred because it focuses at my hand. This is a very actually depth sensor of the cell phone creates this problem. You know that familiar with the phone sensors, etc. That whenever we place the hand, so depth sensor of the telephone, basically of the cell phone, focuses on my hand. AP. Let me see the answer. Very good. 5.47. Okay. 5.47. I'll try not to enter my hand. 5.4 centimeters. Next time, inshallah, I'll try to use a longer pencil in which my hand 47. Actually, to erase this, I have to use my hand, and that's why I'm also speaking now. So you can listen to my words carefully. If you cannot see the thing clearly, almost we have 6 minutes. We can complete this. The third part. In the third part, the length of OP. The length of OP is required. Well, guys, what should I do to find out OP? OP is required. This is the vertical height of the triangle ACO. Well, OP length is required. What should I do? Seeking your opinions. Very simple. Okay, without wasting time, you can see that this is a right angle triangle. Again, this is also a right angle triangle. Pythagoras. Very good, Bachi. In AOP, in triangle AOP, because AOP is also a right angle triangle. Here is the right angle, and AP side is already calculated, which is 5.47. So we can apply the Pythagoras theorem. I am going to apply it directly. OP square is equal to 12 square minus 5.47 square. So 10.6. Thank you so much, Bache. 10 centimeter. The length of OP. This OP is also calculated. Now the fourth part is the angle of elevation of O from B. This angle of elevation. Basically, uh, actually, it is very difficult for me to show you this O till P. O till P is a line like this. OPB is a right angle triangle. I am going to draw this figure. Already this figure is being drawn like this. So I am making this figure like this. This is O, this is P, this is P, and this is B. Basically, this is the situation. This is the wall. This is the wall, which is at the back side, and this is the base, which is on the ground. So I am only showing this line OP, and this line which is lying on the base, which is PB. PB is on the base. As you know that vertical and horizontal have 90-degree angle between them. You have already calculated OP. OP is basically 0.6 centimeter, and the PB is not calculated yet. PB, I think so. PB is not calculated. So first of all, you have to calculate PB. Let us find out PB with the help of triangle ABP. In triangle APB, first of all, we are going to find out the side PB, because with the help of the side PB, we can find out this angle. Actually, this angle is which is made between PB and side OB. Requirement is angle of elevation of O from B is required. So PB is required. To find out PB, you have already AP. AP is 5.47, and this is hypotenuse, which is 10, and this is a base. In triangle APB, PB square is equal to 10 square minus 5.47 square. So seeking your answer of 100 minus 5.47, 10 square minus 5.47 square, this, and taking the square root of the answer, I got 8.37. 8.37. So this line is 8.37, 8.37 centimeter, 8.37 centimeter. Now to find out this angle of elevation of O from B with the help of the tangent ratio, tangent OBP, OBP is equal to 10.6 over 8.37. OBP is equal to shift tangent 10.6 divided by 8.37. Okay, thank you so much. Many students have already calculated 51.7. 51.7 degree. Okay, guys, so we have solved almost 3 questions from the 3-dimensional problems, and there are certain homework. This question number 3 will be your homework. I'll also paste it on Edmodo. There is another part which I gave you from the previous exercise. This part was question number this question number 13, 3 and 4 part. These are your homeworks, and I hope that you have understood. If you have any question, you can ask me anytime. I'll also upload the same videos to get any concept. You can watch them again, and inshallah the next tomorrow, inshallah the day after tomorrow, whenever a period will be, we'll continue with few more complicated problems from 3 dimension, and then we'll be able to do the past paper, inshallah. And past paper session